Hi there. Thanks for coming in this afternoon. My name is Andrew Burns. I work with the USGS. Specifically, I'm a part of the team of the National Map. We do things like the National Map viewer. And we also supply a bunch of data, the US Topo, which we're here to talk about today, as well as elevation, NHD, some census data, geographic names, and a whole bunch of other good stuff. And just so you know, if you have any questions at any time, let me know, and we can take it from there. I'm pretty informal, and hopefully you guys can get something out of this. And this is kind of using GDAL to translate US topos, taking that GeoPDF and turning it into something different, from a GeoTiff to JPEG. Today I'll be talking about GeoTiffs, and then some use cases and some samples and where we're going in the future. All right, and originally this came up because we get a lot of questions all the time from our customers, like we want different formats for this US Topo. In my opinion, I'm not a fan of PDFs in general. They tend to be heavier. They tend to be limiting on like a GIS power user, and a lot of our people are looking for TIFFs or JPEGs that they can put into some sort of desktop ArcGIS or QGIS and be able to add it to their maps and actually get some information out of the data. So a little bit about the US Topo program. Just so you know, US Topo, started 2009, is not equal to the historical topo maps. A lot of people get this mixed up. This is actually a new program that I think they started thinking about it in the early aughts, the early 2000s. And finally released it in 2009 with this updated version using the GeoPDF. And the historical topos actually started in the 47 and went up to 92. And these are like those metallic plates. Actually, they were selling off last year. You could buy an actual plate, and they'd print these maps onto the plates. So that's what this US Topo revision is trying to recreate, the popularity of those original US Topo maps. So these, again, were inspired by the US Topo, and it's an automated process. The old US historical topos were done by hand, often made into these large metallic plates that they'd print on. And we've put it into like a 3-year update cycle, so there's roughly 55,000 topo maps, so that works out to about 18,000 maps a year created. And they're creating this layered GeoPDF map. So we get everything from ortho imagery to hydrography, boundaries, names, transportation, and then contours and shaded relief. And people find this product, people love this product. We have roughly 10 million downloads a year for these GeoPDFs across 55,000 maps, and that's US and our territories. And as well as 18,000 updated per year, and that's with new, fresh national data sets. And it's really just a reboot of a very popular program that we're trying to kind of enliven maps again, right? So here's the downfalls. People aren't fans of the larger file size. And that's really 22 megabytes per file. That's the average. It goes up to almost 40 megs and down to about 15. For ArcGIS users, you need a proprietary software plugin, TerraGo. And we also use a TerraGo plugin to actually create these. Also, I'm sure you guys notice PDFs on mobile phones are not fun to use. They do not work with our modern customer. And really, it's an additional process for a lot of GIS power users to actually get information out of this data. So that's kind of where we look to GDAL to kind of see what we can use with this software to hopefully kind of empower our users a little bit better. The great thing about GDAL, you can translate it into a whole bunch of different formats. You can customize the map data, so you can actually pick out specific layers. You can clip it to the neat line of each map, and then from there you can mosaic a whole bunch of different topos together and build a larger, seamless map. And that's really kind of the overview of the program. And then now let's get into some of the basics of how we actually do it and how we're starting to do it at the US Topo production. So a little background setup. You're going to need GDAL 110 or above. You can use 1.8, but that's only to read. And then you're going to need a driver. If you're not familiar with it, These drivers have a whole bunch of different formats, and they're kind of not built into the standard install process. And depending on your platform, it can be easier or harder to use to set up with the driver. But the three main ones are Poplar, PDFM, and Podofo. We actually use Poplar at the USGS, and we're using version 2 of GDAL. That's kind of our initial setup. So say you got everything loaded and you're ready to go. This is how you know GDAL info dash formats. And that will give us a huge list of everything possible. And if you want to recreate this yourself, you're going to make sure you see PDF dash raster vector, and that's how you know it's enabled and you're ready to actually get started getting to kind of munge some of this data. So from there, you want to take a look at the metadata of each GeoPDF. So you get a whole bunch of good stuff when you do GDAL info. And you get stuff like projection, creation date, author, bounding box, neat line. And then when you do this special flag here, you add a metadata layers. That'll actually give you every single layer we have in a Topo PDF. So we've got the map caller and the map caller elements. That's going to be your legend and your barcodes and your title. You got the map frame, and that's all the data with inside of that. That's your projection, your grids, your names, your structures, your boundaries, your transportation, also your contours and terrain. And essentially, it's broken down into kind of three major data groupings: the map caller, the map frame, and then also the imagery. So each topo has ortho imagery, mostly NAPE, the most up-to-date NAPE we have. So if, depending on the state and the time, it's within the past year to 3 years old, depending on the state and the time of the extract. But this is a general kind of hierarchy of how our US topos are set up. And actually, one kind of downside is not all topo is created equal in terms of the sub-actual layers within the map frame. Some have additional federal admin boundaries and additional naming conventions depending on what part of the US you're in. So it can be confusing if you're trying to do the same process over and over to a large set of topo maps, and then you find out, hey, I don't have this layer in this single topo. So that's kind of a gotcha I wanted to mention. So let's kind of take a look at some layers. And essentially, thanks to GDAL, you can break out every single layer into its own file, just if you want to look at. We go from the map frame and collar on the top left, and you can see the grids, different names and labels to woodlands. We've got our hillshades, ortho imagery, contours, transportation. And so essentially with the GeoPDF, one really nice thing I guess about them is if you can actually munge or take control of the data, you've got a lot of data to work with, so you can really output some interesting stuff and kind of cater it to your project or your map and build a nice base layer. So we'll go into kind of customizing and some of the commands you'd want to use and then kind of some best practices. All right, so the most simple thing you could do is just say GDAL translate, give me the format, and we're going to do GeoTiff. And then we'll say a random US Topo PDF, right? And then we can create a US Topo.tiff. And that will create every single layer we just looked at into one large file. And essentially everything on here you can see will be built into your own rasterized TIFF. So next, the two main things for actually getting down and picking out the data you want is GDAL PDF Layers off or GDAL PDF Layers. And that either you choose to turn something off or choose to turn something on, depending on normally if there's more layers you want on, you probably want to turn off the less layers and vice versa. And these are essentially configuration options for GeoPDF, and it's all in the GDAL format, or the GDAL docs if you're looking for PDF format. If you've ever looked at the GDAL docs, they can be kind of dense. but there's a lot of good information, and you just take your time and read through it and parse through it. You'll find a lot of interesting stuff, and you can play around with a whole bunch of different options. So essentially, those 3 commands, so that gives us right there, that's every single layer we have on the far left. This is just our vector data product, and that'd be closest to our historical topo maps everyone kind of thinks of. And then this is just our terrain data. If you wanted shaded relief and just contours, that's kind of the basics of how to pull something off. And then let's say we want to actually clip all this good data to an image without that map caller. So kind of fair warning, I wrote this on a Linux box, but so some of these, if you're not familiar with Linux, may seem different, but we'll walk you through step by step. So first step, we want to grab that neat line geometry so we know where to clip it by. And so essentially, I just set it to a variable called NLWKT. And neat lines come in well-known text format if you're not familiar. It pretty much says what type of geometry is, point line, polygon. And then it's literally a series of points within parentheses. It's kind of a tough format, but that's what we've got. So I say, hey, GDAL info, I want the info for my US topo. When I get that, I want you to pull out the line that says neat line. And then I want you to trim everything off and just give me the polygon. And that's what that first line says. And that will give us essentially the well-known geometry so we can actually create a clipping layer. In my experience, I haven't found a good library within GDAL or Ogre to transform well-known geography into another clipping like a shapefile or GeoJSON or KML or whatnot. And I actually came across this project from Mapbox called Well-Known. It's built on top of Node.js, but it's a command line that will essentially convert your well-known geography into GeoJSON for you. And once we can get it into GeoJSON, we can actually clip out our data. So all I'm saying here is, hey, here's my neat line well-known geometry. I'm going to tell well-known to take that geometry and convert it into a GeoJSON. One thing to make sure of, well-known and well-known text don't know what projection you're in. So in this next step, I wanted to come down here and I want to make sure to set my projection correctly, right? So we say, hey, Ogre, I want you to put out some GeoJSON for me, and I want you to do the source geometry, or the source coordinate system as whatever coordinate system you would be in. For this, I did a Raleigh West topo, and that would be that's EPSG 26917. And I say, hey, create a neat line out of our unprojected GeoJSON. And then once we do that, it gives us a nice, beautiful little GeoJSON polygon that we can use to clip out our data. So from there, we use GDAL warp, and we can clip out our topo and our decided lines, our decided custom topo into just the data itself. And thanks to GDAL warp, I say, hey, GDAL warp, I want you to make all of the no data values, everything outside of the clip, so the map caller, to be alpha. Here's my cut line. It's this neat line GeoJSON. Here's my input US Topo TIFF, and this would be a TIFF you created earlier. And then here's my clip version of it. And so essentially from there, it gives you a nice clip. And so here's Raleigh West. The blacked out area is the no data. If you were to use this in like QGIS, it'd be alpha, so you couldn't see it. It'd be clear. And there it is. There's your data. And essentially from there, we can repeat this process across the nation to build a large seamless map if we wanted to, and kind of really make a topo beyond just the 1 to 24,000 7.5 minute quads. So also, these are some good points. So if you want to try it yourself, these are like kind of my recommends for everything, because there are inconsistencies between each one of the topo maps, especially by export year. Is you always want to turn on or off your layers. That's your main key to know how you're actually going to kind of unleash this data. You're always going to want to compress because it doesn't compress by default. So sometimes, like when you're first trying it out, you realize you created like a 200 megabyte file from a 25 megabyte PDF, and that seems terribly inefficient. Also, GDAL PDF DPI, so that's dots per inch. And surprisingly, they go anywhere from 600 to 150, depending on the export, and I haven't found any good documentation, even in our own workings, to figure out which exports are which. So I always set it normally to 300. So at 600, a pixel would be equivalent to a meter, and our data is not that fine to actually need that. So I figure, 300 is a decent enough for if you want to print it, or if you actually want to create a mosaic and maybe turn it into a web map or a larger scale map that you want to use in your desktop software. And then also the GDAL PDF band. So some of our topos, again, come in the 3-band RGB, and some come in 4-band RGBA. So to keep it consistent, I always go with the 3-band because for the most part, we're just going to create a mosaic on the bottom, and we're not looking to create any sort of transparency between the actual data layers. And also, if you go 3-band, that's going to help keep the file size down depending on what your use case would be. So again, caveats. Watch out, pixel resolution, band count, map layers. Like I said earlier, there's some map layers that are on some topos and are not on others. Also naming. This is disappointing, but I've found some layers which should be the same are named incorrectly or named differently. Example, projection in grids versus projections in grids. You got to watch out if you do want to do a similar project for yourself. But kind of going forward, what can we use with this? And essentially at the USGS, we have finally gotten our foot in the actual cloud doorstep. We've kind of started testing out, we've got a contract with Amazon, and we've started testing both data storage. Actually, all of our US topos are available now in S3. So if you want to do some massive processing and you're used to Amazon, if you have a system set up in Oregon, you can use all of our data you want, and it's fast and quick and free for transfer rates. So what are these kind of possibilities? And so our first step we're kind of looking is on-demand translation and customization. And that's kind of where everything started. People want more options and other options and better customization. So we're going to look at possibly building a service on demand to create topo maps for you, depending on maybe a few set of custom topo maps, like a terrain specific or vector specific or hydro specific, just kind of depending on what some of our customers are saying. Also, again, storage, everything for the US Topo is now up on S3. Also, it allows us for some batch processing. So if we wanted to, again, build out a gigantic base map of a seamless topo, we can do that. And it really helps us to kind of build a web map based on our rasterized topos and really finally create an actual one-to-one. Because if you're familiar with the national map, our base map for the national map does not, it tries to, but it does not reflect our topo product. And actually, we've started doing a little testing. Here's kind of a rough benchmarks. So this is, it takes about 60 seconds per topo to create a GeoTiff. We could do, 60 topos per hour, a total of 917 hours processing. And then based off of Amazon pricing, if you were to use a C4 large instance, which we found has been a pretty good kind of best bang for your buck, we can get it down for under $100, and you yourself could actually process every single topo, all 55,000. And kind of from there, I want to open it up. Here's some resources, information about the US Topo, kind of the GDAL docs. If you're not familiar with GDAL, there's actually a GDAL cheat sheet on GitHub. Forget his name, but D.W. Watkins, I think, works with New York Times, and he's got a really good complete cheat sheet if you want to see about all the commands, and then some information about the formats and the well-known the command line I use to create the GeoJSON from our neat line. So I guess I'll open up to questions. What do you got, if anything? And let me know. So do we have any issues with edge mapping, and do they line up nicely? So far, there is actually a little bit of overlap in most of our topos already, so that's a good thing. One thing we have found is because a lot of these topos for the labeling is still done kind of by hand and by eye, what you'll see is you'll match them up and then there'll be multiple labels along those seam lines. And so that'll look a little funky. But other than that, and especially if you're going just like with the data itself, it seems to work pretty well. You got to watch out for projection issues, especially if you're going from like a UTM into a Web Mercator or a WGS. Any other questions? Yeah. So when you get it in the US Topo, we don't actually have that information in there. It's just, I think 0 to 256. It's an 8-bit color range. I actually haven't done enough testing on doing seamless with just terrain. Our main focus has been on the vector data, but I'd imagine you could run into problems, especially if you go from like the Rocky Mountains into even just right down the road. It's kind of the start of the Great Plains, and I'm sure we'd see some inconsistencies, definitely in the shaded hill. In the back.
How is woodland coverage generated? Is it correlated to the names that you have in there or derived from the names?
Tell you the truth, how is the woodland layer generated? I believe it's actually derived from the national gap coverage, or the Southwest Gap. And yes, National Land Cover Resource. I think that's where we actually grabbed that out of there. There may be some additional workings we do on top of that, but from my experience, it's been like we've had that data set around forever, so I don't know how updated that one is because that's not our bread and butter, but yeah. Also, if you guys want to recreate these yourselves, I put up a little README with the entire on GitHub here. And it's got the neatline GeoJSON created if you want to use that. And essentially it goes through the steps kind of one by one with all the actual configurations we use on a lot of our projects. And if you're interested in getting more into it, definitely send me an email, aburns, B-U-R-N-E-S, at USGS.gov. I've got, so essentially the top of the actual program, and then within there's a whole bunch of additional information about the US Topo. Oh, yeah. AP Burns, and then translating US Topo with GDAL, if you want to look it up on GitHub. And then it's just a README with some quick commands, and hopefully it's enough information to take it from there. If not, throw up an issue, and I'll definitely respond anytime. Anything else? Oh, if you want, also at the phos4gna.org, you rate what you thought of the talk. I prefer negatives, so that way I never have to come again. No. Thank you, though. I appreciate your time, and come find me if you have any other questions.